Hello, hi, welcome. My name is Yoker Anya. Welcome to my mini trigonometry class. Today we're going to learn how to graph sine, cosine, and tangent functions. Our first function will be y equals sine of x. And instead of using numeric values, we're only going to use radians. Now, first of all, we need to figure out the period and the amplitude. If we take a look at this unit circle here, we can see that it starts at 0, pi over 2, pi, 3 pi over 2, all the way back to 2 pi, making this a full period. Amplitude is going to stay 1, since the values only ever go to -1 or 1. We know that at 0, sine, the y value is 0. And then once we approach pi over 2, the y value becomes 1. Pi, y becomes 0. And then once we approach 3 pi over 2, becomes -1. And once we come back full circle to 2 pi, the y value goes back to 0. Now that we're adding a curve, we can see the pattern in the period. Alright, next off, let's try for sine of x. Our general rule of thumb is we need to find the amplitude, the period, the vertical shift, and the phase shift. So let's do that. We can find the amplitude by taking the absolute value of a, which is in front of sine. So the absolute value of a, which is the absolute value of 4, is 4. We're going to turn this 1 and -1 into a 4 and -4. And then we're going to find our period. Our period stays the same since there is nothing in front of the x. From here, we have no vertical shift or phase shift. We can just begin graphing. So remember from last time that sine at 0 is 0, and then at 4, no longer 1. And then at pi, it goes back to 0. 3 pi over 2, oops, it's -4. And then all the way back to 2 pi at 0. When we graph it, it should look something like this. And our new amp is 4. Y equals sine of x plus pi over 2 minus 1. Now if we refer back to our transformation formula and our rule of thumb, let's solve for this. So first, amplitude. There's nothing in front of the sine, so amplitude stays 1. Period. We can check out the period by doing 2b. We can check out the period by substituting b into 2 pi over b, but since there is no b, it just becomes 1, which is 2 pi. This is your new period. And then the vertical shift would be d. D is -1, so the vertical shift is going to be -1. The phase shift is going to be, well, I guess this should really be a negative since this is always going to be the opposite operation, but it's not necessarily like that. So since we have a plus pi over 2 in the parentheses, we're actually going to do the opposite and do negative pi over 2. Since we're doing that, our graph is going to change a little bit. So instead of starting from 0, 0, where we usually do, we're going to do our phase shift back to negative pi over 2. So this is our new starting area. Let's just draw like a little dotted line. And we also went down 1. So instead of starting from 0, we're going to start at -1. So this is our new starting place. And then from there, we can just solve and substitute. So 0, 0. At 0, it would usually be a 1, but now it's going to be 0. And then at pi over 2, it's going to be -1. And then pi is going to be -2, actually. And then it's going to come all the way back up to -1. And then eventually go to pi over 2. And so you get this whole thing. But this should really end here. It should end here. But if you want to keep going, keep going. Now we're going to be looking at cosine functions. Cosine functions and sine functions are very similar. However, cosine, instead of starting at 0, 0, starts at 0, 1. So let's just do that right now, and we can pull up our mini circle and refer to that as well, because since sine is the y value, cosine is going to be the x value. And we can see at 0, cosine is actually at 1. At pi over 2, cosine is 0. At pi, cosine is -1. At 3 pi over 2, cosine is 0. And pi over 2, cosine is back at 1. And once we connect this all together, we can see we have created ourselves a cute curve. And this is our full period, 2 pi. And this is our amplitude, 1, 1. Now let's move on to y equals negative cosine 2 pi. This is new because we've never had a negative in front of the cosine before. All this means is that you're going to take your y values and you're going to flip them. That means the whole function is going to reflect across the x-axis. So we know the amplitude stays the same. We just know that the period is influenced, and so are the y values. So let's figure out the period. Period is 2 pi over b, which is 2 pi over 2, since b is 2. The 2 cancel out, causing the period to just be pi. And then we have a negative in front of the cosine, which means our y values are going to switch. So now where cosine usually equals 1 at 0 is now going to equal -1. Pi over 2 stays 0, but pi, instead of being -1, now becomes +1. And the whole function changes and flips. And if you just continue this pattern, you can see that the function just becomes the opposite. Alrighty, last but not least, let's figure out how to do y equals tan of 1 over 2x. First of all, we know there's no amplitude because it's a tan function. So we can just move on and figure out the period. The period can be solved by replacing b, which is 1/2. And since we can't have a fraction at the bottom, we have to multiply the top and the bottom by the conjunction. This cancels out, and now you're left with pi over 1 times 2 over 1, which ultimately equals 2 pi. 2 pi is your new period. So we want to spread that across the x-axis near the 0 value. So we're going to split in half and do negative pi to pi as our cycle. Now we've put the vertical asymptotes, we can graph. So we know tan is going to be 0 in the middle, go up to 1, go down to -1, and that is how you would plot your tan graph. And this is what you would call a horizontal stretch. Alright, thank you so much for tuning in and learning how to graph functions with me, and I hope you found this educational. Thank you and have a great day.